Hey, welcome back to another code challenge. So this one I found interesting. It took me more than a couple of hours to actually complete. And I know sometimes it's informative to watch people struggle and how they solve problems, but it was just getting a little long. So I had recorded, I was about an hour and a half, and then I just stopped that recording. So I already have a working solution, and what I'm going to do is I'm going to erase that now, and then we can kind of fill it back in together. And I'll give you my thought process and what I did. So I'm just going to reset this solution here at the very bottom, and we're going to go from scratch. And I guess the problem here is, we're given some formula in words, send plus more equals money, and each digit has to be replaced with a number. And then you have to make the equation still be true. And there's some constraints. So it's only uppercase. Every letter can only assign one digit. There'll be a maximum of 10 unique letters. So presumably 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are the number of characters. And then there's a couple other things that are come important here, like no leading zeros. And then finally this addition thing. So let's go ahead and take a look. The first thing I always do is I print out what the puzzle looks like. What are your inputs? And this is informative just because I like to visually, although we can see it over here, I still want to just kind of confirm what things look like. Okay, so we are getting exactly what they said. Everything is fine. In this case, I wanted to have a kind of object-oriented solution. So there's a lot of pathways and a lot of algorithm here that we're going to need, and it just serves our purpose a little bit better, I think. So I'm going to create a cipher class, and we're going to feed that puzzle in. And then down here, how I want to use this thing eventually is I'm going to create an instance of that cipher class. And I want to be able to say things like cipher.solve. And then down here, I want to be able to return cipher.result. So I need a solve and a result here. So we're going to go ahead and fill those in. And for now, I am going to, we don't know what the solution is, so we're just going to set it to none. But I do know that when this is completed, we are going to return that solution. All right, so if we take one of these things, so we take like this example, let's just talk about the algorithm here. We'll put this in the notes maybe. So maybe we can just kind of up here at the very top, let's just make a quick note. So if we're given something like this, and if we were going to traditionally do this math, we would have like send more, and then there would be like a plus, I guess it's underscore like that, and then it would have to add up to money. All right, so that's kind of traditionally, what we're really looking at. So the algorithm that I'm going to implement, and I'll show you this in a second, is we're going to start with the ones digit. And I'm going to just guess at what I want for y. And I'll start with 0. So 0 will be the digit I'm going to start with. Then I'm going to pick all values of d and e from the remaining digits. So everything but 0, 1 through 9 in this case, that add up to 0. So in that case, it would be like 1 and 9. It would be 2 and 8. 3 and 7, 4 and 6, right? So that's the first pass through. We're going to take a look at the ones digit, and we're going to assume that y is equal to 0, and then all values of d and e must be, so whatever d and e are, they must be something like this. They must be in one of these. It must be like we talked about, 1 and 9, but it could also be 9 and 1. It could be like 2 and 8 because those add up to 10, or it could also be 8 and 2, and it could be 3 and 7, or 7 and 3, and then finally it could be 6 and 4, or 4 and 6. And then right above this, maybe we should just say well, the remaining digits are everything except for 0, right? Because we just plucked 0 from the thing. So then the next level, I'm going to choose one of these. So let's say D and E is equal to 1 and 9. So then I'm going to remove 1 and 9 from my list. And then I'm going to move over to the tens digit. And then I'm going to guess what E is going to be, right? So the next pass is I'm going to have to iterate through all of these here. But let's say we're going to choose 1 and 9. Then our next pass is we compute our remaining digits again. So we'll have 2, 3, 4, 5, 6, 7, and 8. We're going to select the value for E. Now E is already set over here, so we said E was 9. So we have to have N and R have to add up to 9, right? Just like here, D plus E had to be something, we don't know what that first digit is, but the last digit had to be a 0 based upon this. So what we know now is N plus R has got to be something that ends in E, and we already have a value for E because we chose it to be 9. So then we're going to go through all the solutions again, right? So from the remaining digits, what adds up to 9? So 2 and 7. 7 comma 2. Anyways, we're getting a little long-winded. I think you get this idea. This is the algorithm that we're going to do. And it is just kind of figuring out what I do, working backwards from the 1 digit to the tens digit to the hundreds digit to the thousands, all the way back up until I get to a solution, the first one that I find that works. Anyways, I thought maybe they said there could be more than one solution, but maybe I missed that there. But anyways, as soon as we find one solution, then we're out of here. So that's what we got to code up. We got to code that up. So in my solve, what I'm going to have is I'm going to have a start digit. And I'm going to use the word total because this is on the total side. So over here, that's the total. These are going to be the terms. So term 1 is send, term 2 is more, the total is money. And so that start total digit, we're going to start with 0. And then we're going to have a while our solution is none. I'm going to call some method that I don't have yet, and I'm just going to call that kind of bubble the digits up. That's what I'm kind of named this algorithm, is we're kind of taking those solutions that are possible, we're going to bubble those digits up, and it's going to take into it the start total digit. We're going to feed in the current solution puzzle, and we're going to feed in the index that we're working on. So -1 is the last digit on this total, and the total is money. So the last digit is -1. That's a Y, and we're in the 1 spot. And when we want to do the 10 spot, we'll switch this to -2. But I will have to have that function, and it's going to have to do some work for us in a little bit. Right now it doesn't do anything. So back to my solve. I'm going to write this whole function, and then we're going to go and start worrying about the bubble digits up. So I'm going to start with this total digit. I'm going to come back through here. I'm going to have to increase my start total digit. If this is equal to 10, then I've gone too far, and I'm going to break out of this loop. I don't need pass anymore. Okay, so that makes sense. So this solve is a totally complete function now. The only thing I'm going to do is I'm going to copy and paste in a couple of functions that we're going to use to help us out a little bit. So you're watching me type all of this. I'm going to copy and paste in a print function. It's underscore print. It's going to use a self is debug. So I'm going to set this self that is debug to true for now. And then I'm going to copy in the actual solve function because it has a couple of prints in there. All right, so the only thing it changed, I think, is it added this line here. So we're going to run this. Let's run this real quick. We won't have a solution yet, but we'll see. Cyber solve does not like something with indentation. That's a bit weird. There's something going on there. All right, so there's something going on with some spacing down here, but you can see how this algorithm works now. Solve is now starting with the zeros digit. It's going to ones, twos, threes, fours. It's going to run through all the start digits, and we're going to try to bubble up. Then we're going to start with the 0 here, then we're going to go to 1, then 2, then 3, and then we'll just keep bubbling it up and doing these passes down here in this kind of bubble digits up algorithm. I'm going to copy and paste in a couple of more functions here just so we can save a little bit of time on here. We're going to need a function to validate whether our current solution, so given a solution, and again a solution looks like this. So when all the digits or all the characters have been replaced, we're going to have a function that looks like that. So this validate solution, we're going to split apart into a left hand and a right hand side using the equal sign. We're going to get all the terms by splitting apart by the plus sign. So it could be multiple terms, like down here we have 3, and so we'll split these up. So it'll be like 57, 870, 940, 41. If any term starts with a 0, or if the total starts with a 0, we're going to return false because those are not solutions. And that's an explicit thing here, so no leading zeros. Then we're going to eval the left-hand side. So the left-hand side then would be this whole thing where it would say, the number plus another number plus another number plus another number. We're going to eval that and get a number for it. And if that is equal to the value on the right-hand side, then we have a solution. So that's just a validate solution function. That'll come in handy in a little bit. There's another function I'm going to just drop and put in place here that we're going to use in this bubble a little bit here. And this is going to be, what's going on? I'm missing, it's complaining of something here, but I'm not sure if it really is. It still functions even though it's highlighted as red. Maybe it's because of the pass. But I have a function called analyze solution. So again, given the solution, and it could be halfway done. So maybe we've replaced the y with a 0, and we have replaced the d and the e with a 1 and a 9. So you're going to have some digits replaced. So what analyze solution does is it takes the solution and it's going to figure out how many digits are used. All right, so it's going to go every single character in this solution. And if it's a digit, it's going to add it to digits used, and it's going to remove it from digits free. So we'll know how many or which digits are free and which are used. And then we're also going to create a list of remaining characters. So, if we have, for example, replaced everything but this S, it'll say that there's one remaining character left and it's an S. So this analysis will be important later on. We already kind of saw how we were going to use this digits free up here in our algorithm. So remaining digits, that's digits free. All right, so let's talk about this bubble digits up now a little bit. And this is a bit lengthy. So I'm just going to copy and paste a little bit at a time. We're going to put a little note in here, put this in. So here's our note. It still doesn't like that. How do I get rid of that? That bugs me. There we go. Okay, so just a little note, this is recursive. We're going to call this bubble digits up later on down below. And we're going to keep incrementing this digit index to the left. So it starts with the ones digit, and then we're going to go to the tens, and then the hundreds and the thousands. So this is going to incrementally get, I guess, more negative. It starts at -1, then it goes to -2, -3, -4. And we'll always carry with it all the context that we need for the solution. So this solution will be everything like this. That's the first pass, but second pass it'll have some of those characters replaced. Third pass it'll have even more characters replaced. This digit index, like we just talked about, this is -1, -2, -3, -4. That's going to be the digit we're replacing. This total digit is the next digit that we're going to try to replace. So up here, we just guessed y is equal to 0, and we fed that in. So we'll put a 0 in there. And so that's the next digit that we're guessing. So that's what those mean. And we just have a little helper here. This debug, again, we looked at this already. I think I talked about this, but that little print statement is just a flag. If we're running in debug mode, we'll do a print. Otherwise, we're not going to print. And then there is a case in the code later on. You're going to see, if the solution was set, then we're done. So we can just break out early. And because this is a recursive function, there may be a bunch of recursive calls that are still kind of in the stack that need to happen. And so this is just a way for all those recursive calls that are just there already to exit early. Once we have a solution, anything else is just extra work. We don't need to do the extra work, so we're out of there. All right, so the next thing we have to do is we have this total digit, which is kind of 0, and we have our function here, and we need to replace this y with a 0. So that is a bit of easy code here. Just drop and place it, put it in place. And so not just, we're starting with this y, we're going to replace that. But if there's y's over here, then we're going to replace all occurrences of y with that same value. So replace it with total digit. So the character B to replace right now is we're looking at the solution, and this is a -1. So this is the whole thing. We're looking at the last character there. And then I have an if statement here. So if this character is a digit, later on when we get to recursive calls, for example, E on the next layer, E will already be replaced because we'll have replaced it with whatever value we're trying here for this E. And so if it's already been replaced, I don't need to do a replacement. So I'm not trying to do a replacement again. This is only if it hasn't been replaced. So if it's not a digit and this character isn't in a space plus or equals, there is a case where maybe I run all the way back and I get the space. I don't want to be back in that area. So I don't need to replace anything at that point either. Otherwise, I go ahead and I replace that character. And then again, I'm just kind of printing out the solution. So if we look and see where we got right now, you can see here's that first print line right up there. It's telling me, here's my solution. There's no digits replaced. We're at the -1 index. And the digit that we're going to use and replace it is the zeros, which is what this big line indicates. So I'm going to replace that y with a 0, and I end up with, that's my solution so far. We're just guessing, and we're going to bubble kind of these digits back up until we end up either with something that doesn't work anymore, or we end up with the solution. So next thing I want to do is I want to split this solution back into kind of a total, which is on the right hand side. That's the total. And then I also want to get the terms that are on the left hand side. And so this is just doing a little bit of splitting based upon the equal sign, and also for the terms based upon the plus sign. And then I do this exit early again. If I ever run into a case where the very first number in my term or my total is a 0, that is not a solution. And again, that's based upon this no leading zeros technical detail there. Okay, so now we need to do a little bit of the algorithm, like we talked about at the very top. So at the very top here, I just replaced this with a 0. And I have to go up and see what the characters are up here now that are in this ones column. So given my index, which is I'm at the ones column, I'm going to have a D and an E. And I also could have, if you get back here further, this E is going to be replaced eventually. So that's not necessarily E, but maybe it's a number. And when I'm adding up these columns, I need to know how many characters I have, but I also need to know what the total is already. And so that's what we're doing here is we're collecting the total. So we're adding up the total. We're also going to collect up the total number of characters I find. And this is going to be a dictionary because not only do I need to know how many characters I find, so maybe I found an E, but I also need to know that, hey, there was actually 3 E's in that column. And so sometimes the words that they chose, we're going to not just have a single instance of an E, but it could be like 3. And so what we're going to do is we're going to loop over all of the terms, and we're looking at this digit index. If that length of that term has a value at that index, so if that length is, if we're looking at -1 and there's at least a single digit in the term, we'll get either a character or we're going to get the actual value. If that character is not a digit, then what we're going to do is we're going to add to our term character dictionary here that character, and we're going to set the number of occurrences to 0, and then we're just going to increment it by 1. So now I'll know that, hey, there's 1 E. And then I see another E from a different variable. Oh, there's 2 E's. And so all the different terms will contribute to this term characters. If it was a digit, we're just going to track the total. And we need to know that because, again, we try to add up these columns. I need to know what the total is going to be. And it has to be whatever we're going to predict for our next value. So let's go ahead and print here and see what we get now. And so you can see here. So here's send more money. We replaced the Y with a 0. And it's going to see that there's a D and an E in that ones column. There's 1 instance of a D and there's 1 instance of an E. And then there's no more terms. So that's 0. Let's see if we can find one down here where. So here's one where it replaced, it's guessing 9 on the last digit. And then what it's going to do is it's going to find an E. And then it found another E. So there's 2 E's in that ones column. So you can see that there. And so far we don't have any instances where the total is greater than 0. I didn't see anything there. All right, so that's kind of an example of what we're doing next. Now we know how many characters that we're working with. We have a D and an E that we have to figure out all the different combinations next. Now for this next bit, I'm going to import a library itertools. We're going to use that eventually to help us with all the combinations and stuff like that, but let's see where we're at here. At this point, what I need to do next is I need to analyze my current solution and figure out my remaining digits, right? So just like I did up here when we did, I chose 0, I manually computed the remaining digits. And so I'm going to just use this analyze solution helper that we already kind of went over, and that's kind of right there. And it's going to return these 3 things. And one of them is the digits that are still free. And I guess with this, let me just add this print statement. So if we run this again, now we should see, here's D and E. And here's the digits that we've used so far. We've only used the 0. 1 through 9 are free. And the remaining characters that we still need to be replaced are send MOR, and here's the E for it. So those are the remaining characters. So we have send more MONE. These are all number or letters that are already in here. So the S is in there, the E is in there, the N, the D, the M, the O, the R. This E is already there. On the other side, M is already there, O is there, N is there, and then the E is already there. So these are the remaining characters that I have to replace eventually. In fact, at some point, we may end up that in a place where there are no remaining characters. So if the length of this remaining characters array, if it's 0, then I want to check for a possible solution. Right? I don't need to go any deeper. I don't need to try to replace anything else. There's nothing else to replace, but we just need to stop at this point and see if our solution is valid. And so we're going to use this validate solution helper, which is down here. And we already talked about this. Essentially, it's parsing out the left and the right side, making sure that the total in our equation, we'll end up with something like this, and a value on this side. We're going to make sure that that equality is really there. And so if we do find a valid solution, we're just going to print it out. So in this case, so far, we should never end up in this loop. or in this if condition, so we're not going to see any of that. Now the next part is probably one of the trickiest bits. If we go back up to our example, once we start to fill this in, and I'm say back here on say the hundredths digits, so the E, the O, I'm going to choose an N. I'm going to have some values that are already replaced, so that E is already going to exist. And I need to know not just the values here, which is what we just did, but I also need to know the previous digits that have already been replaced. So that'd be the tens and the ones. They should already have numbers in them. If I add all those up, what's the carry digit? Am I carrying a 2 into my column, or is it a 1 into my column, or maybe I'm not carrying any digit into my column? So that was a bit of a trickiness that I kind of missed the first pass through. But I eventually saw it, and I added a bit of code here. So we're going to just copy and paste that code in. And so what this code does is now this calculates the carry value for all the terms that we've already kind of replaced. So if we're on the hundredths, we're looking in the hundreds column, that means the ones and the tens digits have already been replaced. So now here I'm going to kind of loop over all those terms, and I'm going to look for those indexes that are to the right of us. And so what you can see here then is for every single term, I'm going to build up this term number. It's going to be a string. And I'm just grabbing all the characters from digit index. So if we're looking at the hundredths column, that'll be -1, -2, -3, +1. So we're going to go from -2 to -1 to, I won't include 0. So we're just going to go -2 and -1. That's the tens and the hundreds. And we're going to grab the digits that are there. So if they're digits, then we're going to add that to our term. And so all those things that are filled out, I'm going to end up with some term number. It'll be like maybe 15, but as a string. So we're just going to concatenate as a string. If I end up with something that's greater than 0, then I'm going to convert this term number into an integer, and we're going to append this to our list of term numbers. So depending on how many terms you have, I'm going to have maybe a 10, a 15, 25, whatever they are, and I'm going to have this whole list. In fact, let me go ahead and grab, I have a print statement here that I didn't copy and paste in. Let me put this here. So now we can kind of see what everything's going to look like. And we'll test this out again. So just incrementally, we're just kind of going through all the solutions. So the very first pass here isn't going to be very interesting in all these term numbers because there aren't going to be any terms. We're on the very first one. We just replaced the Y with a 0. I have a D and an E. There's no column to the right of this that I can possibly add up. So until we get to a spot where we've started to do some recursion, we're just going to see this information the way it is. So the current sum is 0. You can see the current sum. So that value is just being computed here. So you can see current sum is 0. Once I convert this to an int, we can just keep adding up that current sum. Eventually, we're going to figure out what the carry digit is from that current sum. If the length of it is going to spill over into my next column, I'll know what the digit is. And so we're going to go ahead and grab that digit, and I'm going to put it to this value. So that's the previous digit's carry value right there. And it'll be an integer, and so I'll know what that number is. All right, so the next bits. This is where we're starting to set ourselves up for recursion. And again, this is what we did manually up here. We figured out that, hey, my digits is 0. I need D plus E to be something that adds up to, that has that least common digit or least common value of 0. And I figured out what all of these possible combinations are. And so this is the code that's going to do that next. I'm going to create a list. At the end, we're going to have this total possible combinations list right here, and we can see what they are. And here's where we're using our iter tools. So using iter tools, give me the combinations, and what this is going to spit out is I have the number of free digits, so 1 through 9 in this case. How many am I looking for? I need to take them 2 at a time. So I'm looking for a D and an E. So given that 2 at a time, I'm going to get out of this, then all combinations is going to be an example like 1 and 2 and 1 and 3 and 2 and 3. So if the total digits free are these three numbers and I'm taking them 2 at a time, then it's all combinations of just 2 at a time. 1, 2, 1, 3, 2, 3. Now what it isn't is the reverse of it. So the 2, 1, the 3, 1, and the 2 or the 3, 2. For that, I need to also run this through all permutations. And so then I'll end up with all the different possible combinations. Now, just because I have this combination, this is kind of a theoretical, hey, let's just, I have 5 numbers, I need to take them 2 at a time. This isn't taking into account what they add up to. So now what I'm going to do is, for every single one of those combinations, I have to ensure that that column adds up to the value that I'm looking for. So in our case, it's a 0. So I need to compute a total, and this little for loop is all it's doing is adding up, but it's multiplying by the number of occurrences. Remember, we found this one down here where there was multiple e's. So if there was multiple, this is just the number of those characters. And so I'm going to take whatever the value is in that placeholder, and I'm going to multiply by the number of those kind of characters, and I'm going to add that to my total. And then I can't forget, these are just the total of the digits that I selected in the combination, but I also have to add to this, here's my solution total, the total that we computed from the term. Here is the term total. In this particular case, it was 0 because there hadn't been any digits replaced. And then I also have to add in the carry digit. So if the carry was 0, then I don't have anything to add. But if the other columns are going to contribute a 2 to this one, then I add in the total number of digits. This is probably another one of the tricky spots here, is just to make sure that we're accounting for all the numbers and then making sure that we're filtering out all those solutions that don't meet our requirements. So the least common digit, that's the remainder, if I divide this by 10, has to be equal to the total digit, which is the number that we are replacing it with. So if we go all the way back to the top, that's this number. So that's the total digit. I'm going to make one more line here. I'm going to print out also, just so you can see them all. We'll run this again. We'll see the possible combinations, like we manually did. So we took our starting with our 0 and we replaced the Y. We saw that we had a D and an E, and then we figured out all the possible combinations, 1, 9, 9, 1, 2, 8. So we did this manually up above, and there's a total of 8 of those. So far, we're just implementing this. We did this manually. Next thing is, we're going to run each of these solutions back through our function that we're running here. And so we can start to see this for loop here. So now we have all these possible combinations. So for every possible combination, we are going to now run this for loop, and there's going to be a lot more in here that we're going to add. So we're essentially going to start trying all of those, and that'll be kind of the next little bits here. You're going to see, okay, well, I'm trying this solution 1, 9, I'm trying 9, 1, I'm trying 2, 8, trying 8, 2. But there's more, obviously, that we have to do here. First thing is, this context that we pull in, at the very top, we need to call our bubble digits up function, and we need to set this up so that we have a new context, a new digit index, and a new total digit. And that's what this next bit of code is going to do. So the first thing is, we're going to go ahead and copy our current solution and get a totally different copy of it, because I don't want to ruin this. I mean, this is going to be recursive. This has to stay on its own, but I need to carry that context back up into the bubble function when I call that again. So next thing I'm going to do is, again, I've got a possible combination. This has some digits in it. Now I have to replace in this solution copy. All right, so I have that solution copy. Now I'm going to have to go over all the characters that we possibly have, and I'm going to replace those with their value. So given that this is a possible combination or a possible solution, I'm going to go back in and we're going to replace it. So let's take a look and see what this looks like now. And so you can see here, there's 8 possible combinations. We're going to try 1, 9. Here we start off with a 0. And then what we're saying is D and E. So E is going to be equal to 9. So every time you see an E, you're going to replace that with a 9. So now you have 9 here. There's a 9, and here's a 9. 1 is going to be the D. So you can see every time we see a D, we're going to replace that with a 1. So here's our solution copy right now. So we're just kind of incrementally replacing characters with digits as we guess the solution. All right, the next part is, we need to do the analysis that we had before. We're going to take this new solution, we're going to feed it into our analyze solution function, and then we're going to get the number of free digits and the remaining characters. If there's no remaining characters, then I'm going to test and see if there's a possible solution. At this point, I'm never going to get into here, but this is eventually, hopefully when we are set, we'll have no more characters to replace. So let's go ahead and test and see if it's a possible solution. All right, next thing is we need to start setting ourselves up for calling our function recursively. So this is going to be our new digit index. So this is the current one. I'm at, say, -1. I'm going to subtract 1, so now I'm going to move over to the tens digit. So when I call the bubble function here in a little bit, now we're going to be in the tens digit. It's not, at this point, still just a simple callback to the bubble function. There's a little bit more logic here. And again, this is one of the tricky areas that I kind of got caught up on, is this if statement. So let's go ahead and go through this. So what this is saying is if our solution copy, if the digit, so our new, now we're at the tens, if it's already a digit, that means it's already been replaced. So in this particular case, that's not true. I'm sorry, in this particular case it is true. So you can see here, we had an E over here, so we replaced that E with a 9, and so you can see here is the digit 9. So it already is true. So we're going to end up in here. So the digit total, which is what we're going to feed back into the bubble digits up, is just going to be a 9. So all we're doing is we're just saying, hey, that's already a 9. That's the value that we're going to put there. We don't need to guess what it is. And you'll see in the next case is we're going to go through all the free digits and we're going to guess and make a guess. But here we're just going to set it to that value, which is going to be 9. We're going to send back the solution copy, and now we're in the tens digit, so that's a -2. So that's the case if it is a digit. If it's not a digit, just realizing here, I probably don't need to call this again because I think I just called it up here. Nothing's changed. I'm just going to get rid of this. I don't need that there. Now we'll come back to that. If it broke it, we'll find out here soon enough. So if it's not already a digit, then what I'm going to do is I'm going to go through this list of free digits that I already computed up here. These are all the remaining digits that are there, and I'm going to guess that this next one that we're going to replace it with is whatever the first one is, then the second one, then the third one, then the fourth one. And this is where you can start to see this recursion adding up. And so now we've completed one whole column. What we've done, we've completed the ones column. So that index was -1. So now we're going to go back up through this one, and we're going to look at the tens column, and then we're just going to repeat the same logic. And so that logic is every single column, we're just going to work our way backwards until all the letters are replaced, and then we're going to test our solution. So if I run this now, I think I got all the code in place, and we should see that we are getting our test pass. Now, one of the things you'll see is, for example, the bottom of the test, there's a lot of verbiage in here. So you can see all that recursion. So we're seeing all the different things we're trying. All right, so if we scroll all the way to the end, what we're going to see is this max buffer size is reached, which happens because we're being very verbose here. And that's why I have it so that I can flip this off. So I'll set this to false. I'll run the test again. Now we get the 5 kind of example tests. They all pass. There's not really anything being output here. I think what I'm going to do is, just so you can visually see, maybe we'll just make these normal prints. And you probably will see some of them be printed out, right? So this one, and remember we checked it twice, so we do it down here. And maybe there's some refactoring I can do here. Make this one common function. Okay, so now we see them all. So it's finding, hey, hey, this is the solution, this is the one that works, and that matches up with what the solution that they expected was. And then when you click attempt all, let's see if it does it with the print in there. We pass up all our tests. So it's an interesting solution. There's a bit of complexity in there. I originally had just planned on videoing this from the beginning to the end, but then I got caught into, it was like an hour and a half video. Nobody wants to sit through an hour and a half. I don't even know how long this one is. This is long enough. But anyways, I just decided to carry on with it because I was interested in the solution. But I just went back and just kind of videoed the solution itself so you can see my thought process a little bit more. But we're going to submit this. The difficulty, I guess it was a 3Q. All right, so that's it for this one. We'll see you next time.